Hey there, welcome back everyone. It's just me, Mohammad Vamik, and we will be continuing our second week for grade 9 computer science along with all of you. I hope that whatever we have discussed in the first week is quite clear to you, and I also hope that you have completed all of the lectures, you have completed my in class activities, and you are good to go. So, just in case, if you feel like if there is any confusion you have in chapter number 9 that we have discussed in the last week, please don't hesitate at all. I'm here to help, I'm here to support. You can either post a comment either in MS Teams or just in case you can even type me an email. I'll be happy to respond to that and help you guys with your queries. Other than that, as far as the second week is concerned, for the second week, we are going to discuss the chapter data representation and the number system, right? So, first of all, let me discuss with you that what are we going to discuss in this week. So, first of all, we are going to see that what is binary? How do the computer represents all form of data? We are going to discuss the three different categories of number systems as well. That is a binary, undenary, and hexadecimal. And I believe that right now there may be some unfamiliar names for you, but as we are going to go along with our journey, it will be easy for you to understand that how basically the things are going. So you don't need to worry at all. We are going to discuss here numbering system. We are going to discuss here the binary system. So even before starting the class, I want to discuss with you that in every day of our lives, we are basically using a number system to communicate. For example, right in front of me, I have 8 students. For example, please refill my car petrol for 5 to 10 reals. For example, I went to a restaurant and I ordered there my burger and a cold drink that is basically a deal of 20 reals. For example, I want to purchase a new car that is also a like 40,000 reals or 50,000 reals. You need to understand here that in everyday life, I'm using a numbering system that is helping me communicating. For example, I asked you that you are 7 students, 8 students. So basically this is it. This is to be known as a numbering system that is helping us in our everyday life. Similarly, I also understand and I also hope that all of you are fond of playing games and you might have encountered some examples of errors. And those examples are like, for example, if you have an error of like error E404, error F7, error this cannot be found, or any example you have encountered either in your games or in your daily life, it would be evident to say that all of these errors that you have find one thing is common in those errors, that those errors are basically a combination of numbers and alphabets. For example, if you have an error like error E404, if you have an error like error F7, if you have an error like something else, so this is how errors are that follows the language of alphabets and letters all at once. So basically, uh, if there is an error within the program that can cause unexpected behavior in a game, for example, the character might not move or the key is not being pressed, the programmer needs to find out that why this is happening, what is the reason. And to solve that, what the programmer do is that the programmer search for that piece of code, and against that piece of code the programmer assess that what is going to be the problem. what is the error in this. So similarly, I also need to discuss with you that what is this numbering system, or what is this binary. So you need to understand that basically right now, if for example you are understanding what I'm trying to say, this means that I'm speaking in English, and at the same time you are speaking in English as well. But the problem is my computer system never understands English. There is basically a different language for machines. There is basically a different language for computers. And the language, the name of the language is to be known as binary. That means that, for example, if my computer wants to communicate into machines, so he has his own language that is binary. But for example, if you and me wish to communicate with each other, then we have our language, which is to be known as our English language, right? So, what I mean to say that let's take it one step beyond. So, the chapter that we are basically discussing in today's class is to be known as your data representation. And for understanding this term data, now, if I ask all of you that can you define me what is data? So can you think of it that what do you understand of a data, or what type of data you have into your computers? So basically, I can say that a simple definition of data is that basically a data is a piece of information or facts that basically are collected, processed, and analyzed, right? Like, for example, I can say that a school has a data of all of the students. That means that all of the students are listed into that data. So that data could vary in terms of name of the students, age of the students, with the areas like this. So one thing is sure that, for example, if I have a data, that would mean that I am referring to any piece of information. So for example, if I am referring to the data that is into my computer, I can say that I have music in my computer, I have video files into my computer, and I have images into my computer, I have games into my computer, I have some different softwares into my computer. So these are some examples of the data that I have right into my computer, but how it is represented, this is what is going to be discussed in our today's class. So for example, if it's a music, it is mostly in the format of MP3. If it's a video, it's mostly in a format of MP4. It's an image, it's like PNG or JPEG. If it's games or softwares, you can call it an executable file. But the point is that all of this data is in this form in front of me I because all of us are humans. The data is in this form right in front of me. Why is that? Because we all are humans, and this is the way that makes it understandable for humans. Right? I hope the concept is clear. But there is a big difference between machines, and humans. Now, the data is basically categorized in this format so that it is understandable to me. But if I want the same data to be understandable by machines, so this is going to use the language of binary. Binary basically means the language of zero ones, zero ones. That means that this language only has two options, only two values. And what are those two values? Those two values are either one or either zero. This is the language of your machines. This is the language that your machines can understand. Or I can also say that this is the language that humans cannot understand, right? This is only understandable by machines. So, what do you think? Don't you think that in a computer system, all of the language is converted from a machine understandable language into a human understandable language? And yes, this is the main concept of your chapter data representation. Now, if a computer is referring to its own hardware, that means it is representing the data into its own language, and its own language is binary. But if a computer is representing the data in terms for humans, that means that it has to be into a human understandable form. It is not going to be binary, it is going to be some other language. This is what this chapter helps you to understand data representation. If I summarize it, data is represented to humans into an understandable language, and at the same time, data is represented to machines at the same time in their language. The language of machines is to be known as binary. Now, basically, you know it already that humans process a large amount of data on daily basis. Did you know that when we have a conversation with someone or we are communicating with anyone, we process approximately 60 bits of information per second? That means that our brain is designed to process a maximum of 120 bits per second. So, as a human, right, like for example, I'm talking to you, you are listening to me, we are processing and communicating. But in English, that is a different language, right? Like you can listen what I am speaking, you can process what I am speaking. So this is basically a data representation. Now, I hope the basic concept is clear to you, and as your syllabus says, that understand how and why computer use binary to represent all forms of data. So the answer is that any form of data the computer needs to understand, the machine needs to understand. The first thing it has to perform is that it has to convert itself into binary. If you wish to be processed by the computer, and what is the reason why it has to be converted into binary? The reason is that because it is the only language that is understandable by the computer. Other than that, we need to understand these three number systems. So I hope the concept is clear to you, and let me write it here for you as well, that for computers to understand data, it has to be converted into binary. What is the reason why it has to be converted? Because binary is the language of machines, or you can say it is the language of computers, right? That means that your data representation, or your data is represented in such a way that it is understandable only to computers. This is what I have done so far now. And let me also write with you right in front of you that what is the basic definition of a data representation. So I can say that data representation, it is basically the process of storing, transmitting. Storing means you are saving the file. Transmitting means that you are sending one file to another one. Process of storing, transmitting, and processing data. So data representation means basically the conversions, right? For example, if a computer system, it is to be in binary. For a human, it has to be represented into a human form. So this is it. So other than that, now in terms of this data representation, I'm discussing with you in terms of binary. I'm discussing with you in terms of a human understandable language. And earlier, in the starting of my lecture, I gave you an example of errors, that they are always in a combination of letters and numbers. I gave you an example of games. So these three categories we have discussed so far. So this is going to remain binary as well. The human understand language is your denary, and another name for this language is decimal. And for the ones for error, we use hexadecimal. So these are the three languages that we are going to discuss in today's class. And I hope that I am able to connect the dots. I started the class with the example of errors. The language of errors is hexadecimal because it is in alphabets or numbers. The human understandable language, the language that we use in our everyday life, is your denary or decimal. The language of computers is binary. This is your data representation. This is how your data is being represented. Now we are going to discuss that how they just go through from one format to different format, one conversion to another conversion. And for understanding all of this, the name that I give to all of this is basically to be known as your numbering system. So I can say that I have three numbering systems. I have a binary number system, I have a denary number system, and at the same time I have is a hexadecimal number system. Now we are going to discuss in detail regarding all of these number systems so that it's quite clear to all of you. So first of all, if it is a binary number, If it's a binary number, you know one thing is that this is only understandable by machines. This is a machine language. And if it's a binary number, you know that it has only two options. It is only considered as one, or it is only considered as zeros. Now, the language of binary is like 1, 1, 1, 0, 0, 1, 0, 1, like this, which is not understandable to humans, right? Like if I give you an assignment and I asked you that you have to complete 1100001010 in this, do it make sense? No, it does not, because you don't understand the binary language, right? So this only consists of two values, that is binary, that is either 1 and either 0. So if I am going to count these two values, this goes like 1 and this goes like 2. So basically, what is going to be my base number of a binary? The base number is going to be considered as the amount of values that are into a number system. That is 1 and that is 0, right? Only two values. It is machine understandable, and at the same time, 1 stands for on and 0 stands for off. This is it for the binary part. And just to give you a even better idea of this, have all of you seen buttons like this? You might have wondered that what is this 1 stands for? What is this 0 stands for? So you need to understand that basically 1 stands for that you are turning the button on, and if you have a 0, 0 stands for you are turning the button off. But the question is, sir, 1 and 0 is the language of the machines. It's the language of the computers. How is it possible that it is into switches as well? For helping you understand this, I want to discuss with you that what is basically a circuit. You might have discussed this into physics as well. So if it's a circuit is the one that basically controls the flow of electric current. A circuit is also based on logic gates. Logic gates is basically the structure of the circuit. Now, if I am going to discuss the structure of this switch, if I just remove the top red button, you can see that you are going to have some sort of wires. That makes it one point that this is an example of a circuit. And why it is a circuit? Because if you are going to turn it on, it is going to help you facilitate electricity. If you're going to turn it off, it is going to turn off your electricity. At the same time, if I'm referring to a computer system, do you all agree that all our computer systems, all our machines are created out of circuits? If you are not going to charge a computer, if you're not going to charge your mobile phones, if you're not going to give electricity to your devices, most likely they are going to be run out of batteries and then they are going to be dead. If they are making use of electricity, that means that they are also an example of circuit. And one point is important right here that I will be discussing, that whenever you have circuits, they always follow the language of ones and zeros. They always follow the language of ones and zeros. So whenever you have a circuit, that means that it is only using the binary language, the language of the machines, that is ones and zeros, and binary is base 2. Now let's discuss this denary numbers. So there are basically two names for that. You can call it a denary number, or you can even call it as a decimal number. No need to worry at all. So if there is a denary or decimal number, first thing to be understandable is that I use that into my everyday life. Denary and decimal numbers are human understandable. That means that they are easily understandable by humans. And denary decimal contains all the numbers from 0 till 9. 0 till 9 basically means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it ends here. The reason it is ending at 9, not at 10, because all of these numbers right here are unique within themselves, and all the world numbers, you name it, any number is constructed from this series. For example, if you take 55, right here you have 5 5. For example, if you have 67 67. For example, if you have 44 44. For example, if you have 81 81. So you see all of the numbers are created from this list, and if I'm going to count these numbers, this is going to be 1 2 3 4 5 6 7 8 9 10. So what is going to be my base number? The base number is going to be 10. This is a number that I used in my everyday life. This is a human understandable number. For example, today is the class of grade 9 students. What is 9? 9 is a denary number. I have 10 students in my class. What is this 10? This 10 is a denary number. So I hope this is clear to you as well. Other than that, I have basically hexadecimals. So hexadecimals are the one that I was considering that in the errors part. So hexadecimals are basically a combination of letters and numbers. Whenever you have a hexadecimal, that means you have all the numbers from 0 till 9. That makes them 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then from 10 you have A, from 11 you have B, from 12 you have C, from 13 you have D, from 14 you have E, and from 15 you have is an F. So it ends here, and all of the numbers from 0 till 15, and if I count even the 0, it gives me the base value of 16. That means that the total number of the numbers I have right here are starting from 0 and ending at 15. So if I'm going to count from 0 till 15, it is going to give me 16. So this is the reason that the base value is 16. So I hope it's clear to all of you that what is a data representation, how your data is represented to you in the real world, but at the same time, it is transmitted into machine code so that it is only understandable by machines. What is the data representation? In data representation, we have three number systems. And what is the usage, or what I have it as a three number system, right? Binary, ternary, and hexadecimal. So basically, if it's a binary number system, it's I have discussed with all of you that this is a base 2 number system. That means that it contains only two of the values, only 0 and 1. It has numbers like this, and you are going to write it with a base of 2, right? Like this. For example, all of these are examples of the binary number. For example, if you are writing hello, so hello is hello for you, but for computer system, what is it? It is some code of binary, right? That is like 0 1, it could be any code. So this is to be known as a binary numbering system. What are the some uses of binary numbering system? It is the registers. We will be discussing this into our chapter number 3. What are registers? Other than that, we use it in logic circuits. We use it in circuits. That means that data is processed using logic circuits. For registers, we will discuss this in chapter number 3. What are the benefits of this? Is that it is directly executed by CPU because it is a directly understandable language. At the same time, if I discuss with you denary, so denary is basically a number system that is like integers, right? If I use it in my everyday life and it has a base 10. Other than that, if I'm using a hexadecimal is basically the number system that is closely related to binary system, but at the same time, it is also understandable to humans as well. And this is why it is used in your MAC address, into your error codes, into your IP address, into your hexadecimal code. So I will explain to you in classes that what is an IPv6, what is an ASCII2 code, what is an assembly language, but what is an MAC address. But let me just give you an idea that these are the areas where hexadecimals are being used. So for example, if it's a color system, you might have seen that every color basically gives you a distinct value, and this distinct value is no other than hexadecimal. Why is that? Because it is basically a combination of alphabets and numbers. So hexadecimal is used in color codes in HTML, CSS. For HTML, CSS basically used for creating and designing websites. So for example, if it's like FF00, it means that it is representing the red color. If it is 00FF00, it means it is representing the green color. I have other uses as well, which we will be discussing, right? Like for example, we have MAC address. So MAC address is basically a media access control, an address that perhaps work on the existence of a device that when it was manufactured, what is the model. This is a MAC address. IP address are used in your internet protocol. It is used in the URL, in the website links as well. You might have seen some codes like this into a website, either if you are googling something or you are working on the search engine. It is also used in memory locations. So I hope that the first area is clear to all of you regarding this term data representation, and I'm repeating it back again. The data representation basically means that the process of storing, transmitting, and processing data into a computer, but data is represented into a computer which is only understandable to him. That is the binary language. Data is represented to me in the language that is understandable to me, that is binary. If you are working into errors, if you are working into color codes, if you are working into some other area, that is hexadecimal. So these are the three categories I have from the word data representation. And then I discuss with you what do binary means, what do denary means, what do hexadecimal means, what is their base number, what are their uses. So I hope that it's clear to you. In the next class, we are going to discuss that how can we convert from a binary to denary, denary to hexadecimal, and so on. So thank you so much. I suggest all of you to complete the activity that I'm going to give in today's class. And other than that, we will continue with our next topic. So thank you so much, everyone. Thank you so much. Take care.